Welcome to Physics Videos. Today's topic is the first law of thermodynamics. The first law explains how the state of a system is changed when thermal energy is transferred into or out of the system. Remember that our symbol for thermal energy transferred is the letter Q. When thermal energy is transferred into the system, it has a positive value. When thermal energy is transferred out of the system, it has a negative value.
Is this the same thermal energy that we calculated using specific heat capacity?
That is an excellent question. Yes, it is. We can calculate the energy transferred if we know the mass of the gas, its specific heat capacity, and the change in temperature. Suppose we have two containers in thermal contact with each other. This means that heat can be transferred between them. The container on the left is at a higher temperature than the one on the right. We can consider it as a heat source that can transfer energy to our system on the right. Energy is transferred into the system because of a difference in temperature between the heat reservoir and our system. If the reservoir is at a lower temperature than our system, energy will be transferred in the opposite direction.
So, thermal energy always transfers from a higher temperature system to a lower temperature system.
That is correct when the transfer is spontaneous. This means it happens with no extra help. The basic idea here is the same as when we think about a falling object. If we let it move on its own, spontaneously, it can only fall. If we help the ball by doing external work, we can make it move upward. The same is true for our gas. We can't transfer energy to a warmer system, but it requires external work. The next question to answer is, what happens to the system because of the energy transfer? The kinetic theory for a gas predicts that the internal energy of the gas is directly proportional to the temperature. So, it would seem likely that adding or taking away energy from a gas may have an effect on the temperature of the gas, and thus the internal energy. But, that's not the only possibility. Suppose that the container of the system of gas molecules is flexible and can expand or contract. If the volume of the container changes, then the system of gas molecules had to do work to push it out and expand. Or, work was done on the system to make it contract. Without knowing the conditions under which the thermal energy is exchanged, we can't predict how much of a change we will see in internal energy, or how much work might be done. However, we can predict that whatever happens to the thermal energy that was transferred, we have to be able to account for all of it. Energy must be conserved. This leads to the first law of thermodynamics. The energy that we add or subtract must be found in the change in internal energy of the molecules or as work done by the system. In equation form, the first law states that Q, the energy transferred, is the sum of the change in internal energy, U, of the system, and the work done by, or on the system. In future physics videos we'll look at how to determine the amount of work done and the change in internal energy, based on the type of process that is used to move the energy.
Bye-bye.